Move your eyes to the sides of your head. Everything changes at once. You can now see almost the whole world without turning, close to 350 degrees of it, a panorama that runs from the tip of your nose all the way back past your own hip. Something moving behind your shoulder is already in view. You do not have to look for it. It is simply there, all the time, in the corners of a frame that never closes. What you have lost is the middle. Directly in front of your face, from about eye level down to the ground and out a couple of meters, there is nothing. A hole. You cannot see your own mouth. You cannot see the grass you are eating, or the hand offering you an apple, or the bit going in. To know what is under your nose, you have to smell it, or touch it with the whiskers on your muzzle, because your eyes gave that area away in exchange for the 200 degrees of alarm system running down each flank. There is a second hole directly behind you, and every time you lower your head to eat, the world in front tilts out of focus. So you lift it again, and again, all day, checking. Your eyes themselves are the largest of any land mammal, roughly 8 times the volume of a human eye, wired for movement and for dusk rather than for detail. Red does not exist for you. You are a dichromat, seeing the world in blues and yellow-greens, closer to a human with red-green color blindness. So the bright jump wing that looks obvious to your rider is a smear of muted tone to you. Your ears move independently of each other, and independently of your eyes, swiveling through most of a half-circle to aim at sounds you have not looked at yet. Your hearing runs higher than a human's. Your sense of smell is doing constant work you are not aware of. The whiskers matter more than they look. Those stiff hairs on the muzzle and around the eyes are vibrissae, wired sensory equipment that maps the region your eyes cannot reach, which is precisely the region where your food and everything you might bump into happens to be. People used to shave them off because a clean muzzle photographs better. In 2020, the international governing body of equestrian sport banned the practice outright, effective from July 2021, with disqualification as the penalty, on the grounds that removing them measurably reduces what the horse can sense. Germany, France, and Switzerland had already got there, and there is a moment worth picturing. As a horse gathers itself in front of a jump, the fence slides into that forward blind spot. In the final stride before takeoff, it cannot see the obstacle at all. It has to remember where the fence was, commit its body, and trust the memory. Every clear round you have ever watched contained a second of an animal jumping something it could no longer see. And then the part that organizes all of it. You have no weapon that reliably wins. You have no cover. You weigh half a ton, and you can be killed by animals a fraction of your size working together. And every one of those senses feeds into a single response that has kept your family alive for 50 million years, which is to be somewhere else within a second and a half. That is a horse. Not a metaphor for a horse, not a statue of one. That is the actual animal. And it is worth staring at the design honestly. Because we have spent 4,000 years describing it in exactly the wrong vocabulary. We call the horse noble, proud, brave, loyal, spirited. Almost every one of those words is a human reading of a prey animal's nervous system doing its job. The speed we admire is escape. The alertness we call intelligence is threat detection. The famous sensitivity is a body that has been optimized, down to the bone, to notice and to leave. And this is the animal we bolted our entire civilization to. Farming, war, transport, cities, empires, the movement of people across continents. The most consequential animal in human history is a professional escapee that we talked into staying. And the story of how we did that is stranger, and in places darker, than the poster version. This channel exists to take the poster down and look at what is actually behind it. So if that is your kind of thing, subscribe and stay a while. Start with the running, because the running is the whole animal. That body was assembled by grass. The earliest members of the horse family, around 55 million years ago, were forest animals roughly the size of a dog, browsing on soft leaves, with 4 toes on the front feet and 3 behind, spread wide for soft ground. Then the world dried out and open grasslands spread across continents, and the entire lineage was rebuilt for it. Teeth got taller and harder to survive the silica. Legs got longer. Toes disappeared one by one, until every horse on Earth was running on a single digit per limb, because on firm, open ground, the cheapest foot is the smallest foot. The horse is the textbook example of evolution for a reason. You can watch the animal being redesigned around a diet and a predator, fossil by fossil. A horse stands on the tip of one finger. That is not a poetic flourish. Look at a hoof and you are looking at the third digit of a hand, the middle one, hugely enlarged, walking on a fingernail that has thickened into a wall of keratin. The other digits did not vanish neatly. Two of them are still in there, thin bones called splints that run down each side of the cannon bone and taper into nothing. Remnants of the second and fourth toes, still capable of getting inflamed and hurting a modern racehorse. This body is an animal that gave away everything that was not going forward. Below the knee and hock there is essentially no muscle at all. Nothing. Bone, tendon, ligament, skin. All the meat that drives the legs sits high up against the body, and it operates the lower limb by remote control through long tendons, the way a puppeteer works a marionette. This is why a horse's legs look impossibly thin for the mass above them, and it is the reason the legs work so well. Light limbs are cheap limbs to swing. A heavy foot costs enormous energy at every stride. Those tendons are not just cables, they are springs. When a horse's foot hits the ground, the great tendons down the back of the leg stretch, storing elastic energy, and then return it as the foot leaves. A galloping horse is bouncing as much as it is pushing, recycling energy through tissue rather than paying for every stride out of muscle. It is the same principle as a pogo stick, evolved in an animal that needed to cover distance without eating the grass of an entire county to fund it. The engine feeding those legs is extraordinary even by athletic standards. A fit horse has a maximum oxygen uptake in the region of 180 milliliters per kilogram per minute. An elite human endurance athlete manages around 80. A racehorse is running on roughly twice the oxygen processing of the best runner our species has ever produced, and its heart can move something like 240 liters of blood a minute while doing it. Then there is the trick that has no human equivalent. A resting horse keeps a large reserve of red blood cells parked in its spleen. At the start of hard exercise, the spleen contracts and floods that reserve into circulation, and the horse's oxygen-carrying capacity can very nearly double, on demand, in seconds. It is a biological turbocharger. Human athletes have gone to prison for chemically imitating what a horse does automatically every time it startles. The urgency runs right back to birth. A foal is born after 11 months, and is standing, wobbling but upright, within an hour or two, nursing shortly after, and able to travel with a moving group the same day. Compare that with a human infant, or a puppy, or a bear cub born blind in a den. There was never an option to hide the young somewhere safe and come back. In open country, a newborn that cannot run is a newborn that does not exist by morning. So the horse loads almost the entire investment into pregnancy and delivers a small, functioning adult. And it startles fast. The reaction of a horse to a sudden sound is not a decision. It is a reflex that begins before the animal has identified what it heard. The order is escape first, identify second, which is exactly the correct order if the thing behind you is a wolf, and precisely the wrong order if it is a plastic bag and you have a person on your back. Even the breathing is locked into the escape. A horse cannot breathe through its mouth. It is an obligate nasal breather, everything arriving through two nostrils and a narrow airway. And once it moves into canter or gallop, its breathing stops being voluntary altogether and couples to its stride. 1 breath per stride. Exactly. Because the guts swing back against the diaphragm like a piston at every bound. The horse is not choosing to breathe. The legs are pumping the lungs, which produces something almost nobody expects. Nearly every horse running flat out becomes hypoxemic. The oxygen level in its blood falls, because that narrow nasal airway cannot supply what those enormous muscles are demanding. Healthy humans do not do this. Our limit is usually the heart or the legs. In the horse, the limit is the air, and the fastest land animal we have ever domesticated is, at full speed, quietly running out of breath in a way it cannot fix by opening its mouth. That is the shape of the whole animal. Every specialization is paid for, and the bills come in places we do not usually look. Take the digestive system, which is the most dangerous piece of equipment a horse owns. Horses cannot vomit. Not reluctantly, not rarely. The valve between the esophagus and the stomach is a one-way door. The muscular waves in the esophagus only travel downward, and the tube meets the stomach at such a steep angle that a distending stomach presses the valve shut harder. The system has no reverse gear at all. In a grazing animal that spends 16 hours a day trickling grass through itself, that is efficient. It also means that anything the horse should not have swallowed is going one way, through, or not at all. The stomach itself holds only around 8 to 15 liters, tiny for an animal that size, because it was never meant to receive meals. It was meant to receive a continuous, thin stream. The real work happens far downstream, in an enormous hindgut, where microbes ferment cellulose, produce gas, and keep the animal alive on food almost nothing else can use. Now put those two facts together. A fermenting chamber generating gas, a long, mobile gut with loops that can twist, and no way to release pressure from the front end. That is colic, and colic is among the leading killers of horses. A gut that stops moving, or fills with gas, or displaces, becomes an emergency measured in hours, and in the worst cases, the stomach ruptures before the horse can do the one thing that would have saved it. The digestive design that lets a horse live on grass is the same design that can kill it over a change of feed. The teeth tell the same story of a bargain with a deadline. Grass is a hostile food. It carries silica, essentially microscopic glass, and it grinds teeth into nothing. The horse's answer was to grow enormously high-crowned teeth that sit buried in the jaw and push up continuously through the animal's life to replace what is worn away. Which is why you can age a horse by looking in its mouth, and why we say someone is long in the tooth. But the supply is finite. Push the whole tooth out, and there is no more. A wild horse whose molars run out is a horse that starves in the middle of a field of food. And that, not predators, is what eventually finishes many of them. We extended equine lifespans enormously with dentistry and soft feed, and in doing so we routinely keep horses alive past the expiry date written into their own jaws. The legs carry a similar sentence. Everything that makes those limbs light and fast also makes them nearly unfixable. Below the knee there is almost no muscle to protect the bone, and very little blood supply to heal it. A breakdown there is often not a clean fracture but a shattering, driven by an animal moving at 50 or 60 kilometers an hour on a column of bone the width of your wrist. And a horse cannot be put on bed rest. It has to stand. So when one leg fails, the other three take the load. And within days, the tissue that suspends the coffin bone inside the hoof begins to fail under weight it was never built to carry alone. That is laminitis, and it is agonizing. It is what killed Barbaro, the Kentucky Derby winner whose shattered hind leg was surgically rebuilt with more than 24 screws, and who was healing well until the healthy hoof on the opposite side collapsed and 80% of it had to be removed. He did not die of the broken leg. He died of standing on the good one. Nearly everything that goes wrong with a domestic horse traces back to the same collision. This is an animal designed to move about 16 hours a day, eating small amounts almost continuously, inside a group it can see. We keep it in a box, alone, and deliver its food twice a day in large portions. Ulcers, colic, weaving, crib biting, box walking, the whole catalog of stable vices are not character flaws. They are what a trickle-feeding, constantly moving herd animal does, when the three things its body assumes are all switched off at once. Even sleep is a compromise the horse has not fully solved. The famous ability to sleep standing up is real, and it works through a stay apparatus, an arrangement of tendons and ligaments that locks the joints so the animal can doze upright with almost no muscular effort, ready to run. But that only buys the lighter stages of sleep, To enter rapid eye movement sleep, a horse has to lie down, because in that phase, muscle tone disappears entirely, and a standing horse would simply fall. So this animal, which evolved to never be caught lying down, still has to lie down flat for roughly 30 minutes out of every 24 hours, or it starts to break. Horses that do not feel safe enough to do it, or that are in too much pain to get down and up, accumulate a debt.
Eventually, the body takes what it needs anyway, and the horse slips into that phase while standing, loses all muscle tone, and collapses. Vets see it regularly, often misread as narcolepsy, and it usually shows up first as scuffed knees. A horse with grazed knees and no explanation is frequently a horse that has not been able to lie down and sleep. If the body has been read wrong, the mind has been read worse, and mostly in the same direction. The most persistent story in the horse world is that a herd runs on rank. There is an alpha stallion guarding the perimeter, and a lead mare who decides where everyone goes, and countless training methods are built on the idea that a human should become that lead mare. It is a satisfying model. The field data is much less obliging. When Constanza Kruger's team watched free-ranging horses near Frosinone in Italy and logged who actually started group movements, only stallions performed herding, driving the group ahead of them, while departures were initiated by mares of any rank at all, high or low. A separate study of Przewalski's horses published in 2015 found much the same thing, with different individuals starting movements, and no one animal reliably better at getting the others to follow. Leadership in a horse group looks distributed and situational, rather than throned. That matters beyond trivia, because a training philosophy built on being the alpha of a hierarchy that may not exist in the form we imagine is a philosophy built on a misreading, and the animal pays for the misreading. What the horse is actually doing, constantly, is reading us. In 2016, a team at the University of Sussex showed 28 horses large photographs of the same two unfamiliar men, once smiling, once angry. No training, no reward, no cue from the handlers, who could not see which image they were holding. Facing the angry photographs, the horses turned to look with the left eye, which roots to the right hemisphere, the sides specialized for processing threat, and their heart rates climbed to a peak faster than they did for the smiling versions. I want to be careful here, because this study got a statistical challenge in the same journal, arguing the original comparisons could not carry the conclusion. The authors reanalyzed their heart rate data, and the effect held, and the finding has since sat inside a much wider body of work on how horses read human faces, voices, and attention. So the honest version is not that a horse reads your mood like a mind reader. It is that a photograph of a stranger's face, with no other information attached, measurably moved these animals' hearts, and it moved them in the direction that a praise specialist's nervous system would move. A follow-up from the same Sussex group pushed it further. Horses were shown a photograph of a particular person looking either angry or happy, and then, hours later, met that person in the flesh, now with a neutral expression and handled by someone who did not know which photograph the horse had seen. The animals behaved more warily toward the people they had previously seen looking angry. They had not just registered an expression, they had filed it against a face and kept it. That sensitivity runs both ways, and we have been slow to notice the horse talking back. A team at the University of Sussex built Equifax, a coding system for equine faces based on dissecting the underlying musculature and then analyzing 15 hours of video of 86 horses, and cataloged 17 distinct facial movements. Humans have 27. Chimpanzees have 13. Dogs have 16. The animal we describe as inexpressive has a facial repertoire larger than a chimpanzee's, and we simply never built the dictionary. They will also tell us things directly, if we build them a way to speak. In Norway, Cecilia Maydell's group taught 23 horses to touch one of 3 symbols on a board. A horizontal bar meaning, put my blanket on, a vertical bar meaning, take it off, and a blank square meaning, leave things as they are. 10 to 15 minutes of training a day. Every single horse, 23 out of 23, learned it within 2 weeks, and then the researchers waited for the weather to change. The answers were not random.
On mild, dry days, the horses asked to have blankets removed or asked for no change. On cold, wet, windy days, the ones standing there without a blanket asked for one. They had understood not just which symbol produced which outcome, but which outcome they wanted, in conditions that had not yet happened when they were trained.
Given a vocabulary of 3 words, a horse used it to file a request about its own comfort, which raises the obvious question about the other 4,000 years, during which we were the only ones with a vocabulary. Now the part that changed recently, and changed completely. If you learned anything about horse domestication before about 2018, it is probably wrong. For decades the story ran through Botai, a culture in northern Kazakhstan where, around 5,500 years ago, people were corralling horses, milking them, and putting something in their mouths. Earliest horse herders, earliest bridles, obvious ancestors. Then Charlene Gaunitz, Ludovic Orlando and colleagues sequenced 42 ancient horse genomes, 20 of them from Botai, and the family tree came out backwards. Botai horses were not the ancestors of modern domestic horses. They were the ancestors of Przewalski's horse, which detonates something else.
Przewalski's horse, the stocky, upright-maned animal of the Mongolian steppe, has spent a century as the last true wild horse on Earth, the one species we never tamed. If the genomes are right, it is not wild, it is feral. It is the descendant of animals people herded 5,500 years ago, escaped back into the steppe and left there so long that we forgot. Follow that through. Mustangs are feral. Australian Brumbies are feral. Przewalski's horses are, on current evidence, feral, which means there are no wild horses left anywhere on the planet. There are only horses that got away, and the last of the genuinely wild lineages went extinct without anyone recording the moment. So where did our horses come from? That took 3 more years and a much bigger net. Pablo Labrado and a large international team assembled 273 ancient horse genomes spanning Eurasia and published the answer in Nature in 2021. The homeland is the Western Eurasian steppe, specifically the lower Volga-Don region. Around 4,200 years ago, one local population of horses started expanding, and over the following centuries, it replaced almost every other horse lineage across an entire continent. Anatolia, Iberia, Central Asia, Siberia. All of them had their own distinct horses before this. Afterwards, they effectively did not. Now here is the detail that should stop you, and it is the reason I wanted to make this video. When the researchers looked for what had actually been selected in this winning lineage, 2 genes stood out above everything else. One was GSDMC, associated in humans with chronic back pain and spinal problems, and linked in horses to body conformation and back strength. That one is intuitive. A back you can sit on is the whole point. The other was ZFPM1. It is a gene involved in the development of serotonin neurons in the brain, and in mice, knocking it out produces heightened anxiety. In the horse, the variant was selected in the direction of a calmer, less reactive animal. And a 2025 analysis in Science, modeling when selection began at each locus, found that ZFPM1 came first. Selection on the anxiety pathway appears to predate the intensive selection on the back by centuries. Read that in plain language. The first thing our species deliberately changed about the horse was not its speed, or its size, or its strength. It was its fear. We spent thousands of years standing next to an animal engineered from the ground up to flee. And the modification that made everything else possible, the saddle, the chariot, the cavalry charge, the plow, the pony trap, was turning the volume down on the alarm, not removing it. You cannot remove it, and the animal in your field still has all of it. Just quiet enough that it could be persuaded to stand still while a predator climbed on its back. Everything after that is history moving at a new speed. The Sintashta chariot, the spread across Eurasia. The fact that these horses arrived in Asia together with a language family and a wheeled design. And a return journey that reads like fiction. Horses evolved in North America. The whole family, over tens of millions of years, took shape on that continent and spread out of it across the Bering Land Bridge into Asia. Then, at the end of the Ice Age, they went extinct in the place they came from. Every wild horse in the Americas vanished.
The continent that invented the horse spent roughly 10,000 years without one, and the animal only came home in the 16th century in the holds of Spanish ships. What happened next was rewritten in 2023 by a study with 87 authors across 66 institutions, led by William Taylor, and built jointly with Lakota, Comanche, Pawnee, and Pueblo scholars, several of whom are named authors on the paper. They ran genomics, isotopes, radiocarbon dating, and skeletal pathology on archaeological horse remains across the American West. The genetics confirmed Iberian ancestry with later British influx, and no Viking contribution at all. But the dates broke the textbook. Horses were in the northern Rockies and the Central Plains by the first half of the 17th century, spreading north through indigenous exchange networks, and the skeletons show veterinary care, managed feeding, and riding damage from bridles. They were fully integrated into indigenous societies decades before the European observers who supposedly documented their arrival ever got there. The standard timeline was not a record of what happened. It was a record of when colonists showed up to watch. The horse did not spread across a continent because Europeans handed it over. It spread because people who had never seen one before understood what it was faster than anyone gave them credit for. Which brings the whole thing back around to the design we started with. Because everything we then asked of this animal, we asked of a body built to run away. We took a creature whose reflex is flight and marched it into artillery. In the First World War alone, an estimated 8 million horses, mules, and donkeys were killed, most of them not in charges but hauling ammunition and guns through mud, under shellfire, wearing gas masks that barely worked. Every one of those animals was a prey specialist, standing in the loudest place on earth, and staying because we had bred and trained it to override the one instinct that would have saved it. We call that courage. It is worth being precise about what it actually was. The horse was not fearless. Its heart rate says otherwise. Its Equifax face says otherwise. Its whole nervous system says otherwise. It was afraid, and it stayed anyway, because it had been made into an animal that could be persuaded to stay. That is not the same virtue. In some ways, it is a much larger one, and it belongs to the horse rather than to us. Roughly 60 million horses are alive today, by the Food and Agriculture Organization's counting, and a large share of them are still working animals in places where an engine is not an option. Przewalski's horses number around 2,000. Every one descended from about 15 animals captured at the start of the 20th century. Reintroduced onto steppe their ancestors may have left as escapees. So what is a horse? Not the statue in the square, and not the character in the film. It is a hindgut fermenter with a one-way stomach and no reverse gear. It is a mammal balancing half a ton on 4 enlarged middle fingers, with springs where its calves should be, that recycles energy through tendon and doubles its own blood on command and then runs out of air because it cannot open its mouth. It is an animal that must lie down flat every day to dream, and often will not, because the ground does not feel safe. It has 17 expressions and no one taught us to read them, and when we finally handed one group of them 3 symbols on a board, they told us they were cold. And every strange thing on that list comes from the same source. This is what a body looks like when it has been shaped for 50 million years by the assumption that something is about to eat it. We did not tame that. We turned it down at one genetic locus 4,000 years ago and built the modern world on the margin that gave us. Which means the animal that carried our species out of the Bronze Age was not brave and was never trying to be. It was frightened, and it led us on anyway. So my question for you, and I would like actual answers on this one. What is the animal you think we have most badly misnamed? We looked at a horse doing threat detection and called it noble, and we have been wrong in that direction about almost everything with a face. Tell me your candidate below, and tell me what the honest word would have been. If you would rather have animals described the way the evidence describes them than the way the statue does, subscribe. The next one is about a creature nobody has ever accused of being noble.